Welcome back to NCRT class 10th chapter number 12 electricity. Children, in the previous class we learned about combination of resistors, isn't it children? We learned series combination, parallel combination, and also we learned the advantages of a parallel over series and the related numerical problems we have solved. I hope children you are all sincerely practicing the problems very neatly. Okay, in today's class let us start with the topic called heating effect of an electric current. Children, before going into that, I want to give a small information about the effects of electric current. Children, there are mainly three effects will be produced by an electric current. Those are heating effect and magnetic effect. Then the third one is chemical effect. Means these are the effects which are produced by what? Due to what? An electric current. Children, in this chapter, especially electricity, you are going to learn about heating effect of electric current, and similarly in the next chapter you are going to learn about the magnetic effect, isn't it? Suppose if an electric current flows through a conductor, what happens, means what type of effect can be produced, that we are going to learn under it, that is in the magnetic effect. And that is when you go to higher classes or in the chemistry topics, you will come across with what? Chemical effect. Children, means these are generally the effects of electric current. Children, this is also very important, because in 1 mark or 2 mark you may 1 mark, I hope, yes, this is 1 mark question. Name any two effects of an electric current, means you have to write any two. Better you write, children, heating effect and a magnetic effect, because these are related to our syllabus. So better write heating effect and a magnetic effect. Okay children, now we will start with the actual topic, heating effect of electric current. Children, what is mean by heating effect of an electric current? Children, a cell or battery, isn't it children? Cell or what? Battery will supply a energy in the circuit, isn't it children? Generally what happens? A cell or battery acts as a source of energy in an electrical circuit. So the chemical reaction takes place inside the cell. It means that it sets actually the potential difference between the terminals, isn't it children? Suppose if the chemical reaction is taking place inside the cell, means what happens? The potential difference can be achieved at the terminals of the cell, isn't it? This causes what? The motion of an electrons, means it sets what? Electrons to flow, isn't it children? So if this happens, if there is a flow of electrons, means we can produce what? Current there, isn't it children? So generally what happens inside the cell, due to chemical reaction, there exists what? Potential difference between the terminals of the cell, and makes the electrons to flow in the, that is, resistor or system of resistors, and produces a current in it. Means overall what I want to say, means in an electrical circuit, a cell or battery acts as a main source of energy. In an electrical circuit, what is the main source of energy children? Generally a cell or combination of a cell. It means that battery will act as a source of energy. Children, this energy is going to dissipate in other forms, isn't it? Only some part of the energy is utilized in performing useful work, children, whereas rest of the energy, electrical energy, is converted into other forms, which is known as what? Heat, isn't it children? Okay children, let us take an example, that is our everyday life activity. What happens to the fan if it runs continuously for hours together, isn't it children? That is, the blades of the fan becomes warm, means the temperature got increased here. We have passed what? Electricity to the fan, but heat is generated here, isn't it? Because of that heat generation, the blades of the fan are warm, isn't it children? But this heat energy, where does this comes from? Children, When an electricity or electric current is passed to an electrical appliances, most of the energy is utilized in maintaining that, whereas small amount or a part of the energy is converted into other forms. Here it has converted into heat. So because of that reason, what happened? The electric fan becomes warm, means the electrical energy is converted into heat, isn't it children? Heat energy. This dissipation of energy is absorbed when an electric current flows in an electric circuit children, and the meaning is that when an electric current is passed through a high resistance wire such as nichrome wire, such that the resistance wire becomes very hot and produces what? Heat. And this phenomenon, this process is called heating effect of electric current. You know children, this effect is widely used in an working of electrical appliances which are mainly based upon heating, isn't it children? Example, you can take electric iron, isn't it? Then electric heater, or geyser you can take, then electric kettle, then hair dryer children. These are all what? Different electrical heating appliances we say children, isn't it? Because most of the energy they have converted into heat energy. In normally children, in other electrical appliances, only small amount of a heat is generated. Whereas, especially in electric heating appliances such as electric iron, electric heater, electric kettle, hair dryer, toaster, most of the energy is got converted into heat energy, and because of this reason it have a wide application children, because in different electronical gadgets we can use this process, isn't it children? Means actually this all electrical appliances are made by using a heating element children. What is that children? Inside them an heating element will be there, or coil, isn't it children? Generally this heating element or coil is made of a high resistance wire such as nichrome wire, means a wire which have high resistance will converts easily most of the electrical energy into heat energy children. Got it children? Yes, generally what happens means when we discuss about electrical heating appliances, most of the electrical energy got dissipated, converted into what? Heat energy, and the phenomenon or the effect is called what here? Heating effect of electric current children. Got it children? Is the concept so clear? Let us derive an equation for this. What the thing you have to remember here? The definition and examples. What is the meaning of one? Heating effect of electric current means when an electric current is passed to a high resistance wire such as nichrome wire, the resistance wire becomes red hot, that is very hot, and produces heat, and this effect is known as a heating effect of electric current. Example, electric iron, electric heater, electric kettle, hair dryer, geyser, isn't it children? Room heaters you can take. These are all what? A few examples for heating effect of electric current. Now we will derive an equation for that. Let's have a look over this figure. That is, it consisted of a simple things, that is a cell. It consisted plug key, ammeter and a voltmeter and a resistor. Suppose, consider if I is the current is flowing in this circuit through a resistor having a resistance R. Let it T be the time taken. Let T be the time taken through which the charge Q will flows, and V is what? Potential difference. Let V is the potential difference let T is time taken through the potential difference in order to flow the charge, isn't it, children? Now, the work done can be written as work done is nothing but a potential difference into charge. It means that the amount of work done can be written as in terms of potential difference and a charge. So, this can be written as V is equals to potential difference means V and charge means Q. Say this is equation 1, children. W is equals to V into Q. We know that I is nothing but a Q by T. With the help of a definition, children, what the electric current definition says, isn't it, children? Which is nothing, I is equals to Q by T. It means that in terms of Q, how we will write? I into T. So, now substitute what? Q is equals to I into T in equation 1. What it becomes? W is equals to V as it is I into T. Say this is equation now 2. Isn't it, children? Now apply Ohm's law or from Ohm's law. From Ohm's law, we have V is equals to I into R. Isn't it, children? Now substitute this V. Substitute V in equation 2. What is V value, children? I into R. So, V is equals to I into R into I into T. It means that W is equals to I into I, nothing but a I square we can write. Isn't it, children? What has remained? R and T. So, this work done can be written as I square R into T. Assuming that, children, the electrical energy means the amount of a work done is nothing but the heat produced there. So, assuming work done is nothing but a heat, we can write that H is equals to I square into R into T. And the unit of this heat is, we know what? Joules, children. Isn't it? That is represented with the letter J. And this is called Joule's heating effect or Joule's law of effect, children. This is called what? Joule's law of effect. Isn't it, children? What states Joule's law of effect, children? The amount of a heat produced or the work done is equals to the square of the electric current and resistance and time. It means that H is equals to I square into R into T, and it is called what? Joule's law of effect. When we look into this equation, children, we can say that H is equals to I square RT is nothing but a H is directly proportional to I square, H is directly proportional to R, and H is directly proportional to T. It means that the heat produced is directly proportional to square of the electric current through the resistor, and heat produced is directly proportional to the resistor, and heat is also directly proportional to time taken through which the charge Q will flows. It means that if the I quantity has increased, means the amount of a heat generation can be increased. Suppose if we made it into half, means the same heat is also going to be reduced. Similarly, if the resistance of the wire is increased, means the generation of a heat can be more. Because of this reason, children, high resistance wire we will use for the making of a heating electrical appliances like nichrome wire. Got it, children? Because it can convert easily most of the electrical energy into heat energy. Okay, now heat is also directly proportional to time. Suppose if the time increases, means the time quantity increases, means heat can also be increased here. Means these are the factor upon which the heat produced will be depends, children. And moreover, children, while solving the problems, sometimes we will write the electrical energy E is equals to P into T, means power into time. And you know what is the value of a power? Here the power input, which is equals to power input, can be written as P is equals to VQ divided by T, whereas Q divided by T is nothing but a I, children. So we can write that power P is equals to V into I. It means that suppose if the source has to spend an energy which is equals to VQ in time T, means the value of a power can be written as P is equals to V into I. So dear children, please remember these formulas 1, 2 and 3, isn't it, children? And the previously learned formulas, because while solving the problems that is which are based on a heating effect, we will use this formula. Suppose sometimes that is the heat generation in an electrical appliances can also be given in terms of energy. So at that time, suppose if they have not given resistance value, current value, time value, means at that time we have to use P into T, means the power generated over there into time, we have to use that formula. Children, now let us solve a problem which is mainly based upon heating effect of electric current. The question is that a potential difference of 250 volt is applied across a resistance of 500 ohms in an electric current. Means suppose if 250 volts of energy is supplied to the resistor having a resistance 500 ohms, then calculate the current and also heat produced in what amount of time, children? In 10 seconds of time. So what are the given things, children? Given data is, that is potential difference V is equals to 250 volts and that is resistance R is equals to 500 ohms, isn't it, children? Calculate current. Current we need to we need to calculate, and heat produced has to be calculated in given time. What is the time, children? 10 seconds. See, directly they have given in terms of seconds, children. So no need of converting time here. So let us take the formulas. We want to calculate first I, children. See what formula can we use here? Yes, very good. What is that? V is equals to I into R. This implies what? I is nothing but a V by R. Isn't it, children? So using formula I is equals to V by R. Now substitute the values, children. What is I? We need to calculate. So keep as it is. V value is how much? 250. R value is 500. So this 0 get cancels. 5 and 10 5 1 5 2 which is nothing but a 0.5 amperes. So what is the value of a current, children? 0.5 amperes. Got it? Now, using this value of current, we need to calculate what? H value. So, what is the formula, children? Using formula, H is equals to I square into R into T. Isn't it, children? So, keep as it is H. What is the I value? 0.5 whole square. R value how much, children? 500 ohms. T value is 10 seconds. So 0.5 whole square is nothing but a 0.25. 0.25 into 500 into 10. Isn't it, children? So this can be written as 25 divided by 100 into 500 into 10. These two zeros get cancels. 10 5s are 50, isn't it? So 25 into 50. 25, then 5 to 10, 11, 12. So the heat produced is, that is 1250 joules of energy is produced. Children, now let us solve one more problem, that is calculate the heat produced when 96,000 coulombs of charge is transferred in 1 hour through a potential difference of 50 volts. They have given here charge value, means 96,000 coulombs. It is nothing but a charge value they have given, and they have given also what? The time. Isn't it, children? See, they have given in hours, so we need to convert it into seconds, children. And the potential difference V is given how much? 50 volts. By using these data, we have to calculate, children, heat. We know generally the joules heating effect formula, what, children? H is equals to I square into R into T. But only we know that V value and Q value and T value. So before substituting these values in that, we want to calculate what is the current value and resistance value. Okay, children. So let us solve this. That is given data, that is charge is equals to 96,000 coulombs. Then time is equals to 1 hour, which is equals to 60 minutes into 60 seconds, nothing but a 3600 seconds. Isn't it, children? Then voltage V is equals to 50 volts. What they have asked? Calculate heat. That is H is equals to how much? And also we want to know I value, because in the formula we have a I quantity. So I we have to calculate, then R. So children, when we look at these values, charge and potential difference, we can calculate the I value, because the formula of a current, that is a definition of a current, says that I is equals to Q divided by T. By using that formula, we will get a I value. Using formula, I is equals to Q divided by T implies I is equals to, what is the Q value, children? 96,000 divided by T is 3600 seconds. Isn't it, children? So here on cancelling of symptoms, that is what has remained? 960 divided by 36. Isn't it, children? So now this can also be written as that is 1 and 2, 3, 2, 0. Isn't it, children? Now similarly 2 6 then 2 1 2 6 and 0 as it is, 3 8 0, means 80 divided by 3. Still upon cancelling this 80 divided by 3, we will get, that is how much? 3 ones are, because sorry, 3 twos are, isn't it children? 6 2 0 has remained, so 3 6 are 18, 2 has left. If we keep point, then 3 6 are means 26.67 amperes is the current value children. What is the I value? 26.67 amperes. Got it children? Now we use this I in case of a Ohm's formula, that is V is equals to I into R. From Ohm's law we have V is equals to I into R. We want here R, no children. So rearrange that formula. V by I we can write, which is implies R is equals to, what is the V value children? 50 volts. Then I value is how much? That is 26.67 amperes. See children, 26.67 is also same, or 80 by 3 also means same. So in order to make easier for cancellation, I will take better 80 by 3. 50 by 80 by 3, which is equals to 50 into 3 divided by 80 children. So here tens are, isn't it children? 5 tens are, or else here you can go for it directly by 10 table. 10 fives are, 10 eights are, isn't it children? Now 15 divided by 8. So 8 ones are, 8 ones are, isn't it? Then 6 7 has remained, then 8s are, then 7s are, means 1.87 ohms is what? R value. So what is the R value children? 1.87 ohms is the resistance value. Now we have to substitute this I and R, that is I and R, in a H is equals to I square into R into T, that is S. Using once again the formula H is equals to I square into R into T. What is H? We have to calculate, so keep as it is. Then I, nothing but a 26.67 whole square into R value is how much? 1.87 into, what is the time value? 3600 seconds. So upon this multiplying, we will get 47.88 joules is the H value. Suppose in terms of a kilojoules, isn't it? Then divided by 1000, you will get 47.8.4 kilojoules is a H value children. So the heat produced is how much? 4788.4 kilojoules of a heat is produced here. Got it children? Yes, this is a very simple. Suppose if they have given charge values and time and a potential difference value, means first you have to calculate current and a resistance. After obtaining the current value and the resistance, you have to use the formula, that is Joule's heating effect. Formula you have to use. H is equals to I square into R into T. Then you will obtain in terms of a joules. So we need to convert it for a kilojoules. So divide that obtained value by 1000. You will get in terms of a kilojoules children. Got it children? So in today's class we have learned about what is meant by heating effect. Joule's law of effect we have studied, and what is the formula and what are the factors which are going to depend on it, isn't it children? And also we have tried what? Solving a few numerical problems. Got it children? Okay, keep practicing.